All right, so let's look at the two graphs side by side. Down here at the bottom, we have our runner, okay? On the left, I'm representing a velocity time graph. On the right, we have a distance time graph. We only have one runner. We're going to let the runner move at a constant rate by clicking the stopwatch. As the green line moves across, that represents the runner as he moves. Notice on the velocity time graph, okay, because his speed stayed the same, now the line is flat. Previously on a distance time graph, if we had a flat line, it meant no motion. But on a velocity time graph, it means that the speed is constant. Over here, distance time graph looks different. He moved at a constant rate away from his origin. This axis is showing us how far away he is from where he started. Over here, again, we have his constant rate. Here, we're seeing how far away he moved from the origin. Okay, so here we have 6 different velocity time graphs. Let's look at them all and see what they mean. Let's interpret their meaning, okay? If we start over here, velocity is on your y-axis, time is on your x. If velocity is not changing, but it's not at 0, so velocity is remaining constant, but it's not down here at 0, it means that this object is moving at some speed, and that speed remains the same the entire time. So our first graph represents a constant motion. If this line had been down at 0, then that would mean that the object wasn't moving. A speed of 0 means the object's not moving, but the object does have some speed. It's just that the speed is not changing. So graph A is constant speed. Graph B is showing us that speed is increasing with time. Since our speed is increasing with time, and it is increasing in a linear fashion, that means that it is speeding up at set intervals. So it's accelerating, but it is accelerating at a constant rate. Okay? The line goes up, indicating positive acceleration. Come over to graph C. Previously, we learned that if we had a downward sloping line, it meant that they were returning to their original position. This no longer tells us anything about position. It only tells us about speed. The object was moving quickly, and the object slows down. This is a graph of deceleration. It is a constant deceleration, meaning that it is slowing down at a constant interval. What that means, constant interval, is that means that for every second, it's slowing down a set amount. So at second 1, it slowed down 10 meters. At second 2, it slowed down another 10 meters per second. At second 3, it slowed down another 10 meters per second. It is slowing down at a constant rate. This is deceleration. Graph C shows an object that is increasing with speed, but that speed did not start at 0. That speed started when we started graphing this object, it was already moving. It was already moving some speed, and then it sped up. Okay? So graph D shows an object that was already going some speed, and then it experienced positive acceleration. Graph E. Here we see acceleration again. The object was at 0, and it sped up, but the line is curved. This means that it did not speed up at a set rate. This isn't speeding up at 10 meters per second every second. At first, this object barely sped up, and then it sped up a lot. So this is acceleration, and it's positive acceleration, but it is not constant acceleration. And finally, graph F. We have multiple types of motion here. We have positive acceleration from 0 up, and then from B to C, this object remains at a constant speed. Then from C to D, it experiences negative acceleration and slows back down to 0. Constant positive acceleration, constant speed, constant negative acceleration. Okay, let's look at a velocity time graph versus a distance time graph, okay? First, we're just going to look at the basics of a velocity time graph. There's a very important reason why you must always look at what your y-axis is labeled. A distance time graph versus velocity time graph can look exactly the same every place else, but can mean something totally different, okay? So velocity or speed over here on our axis is increasing. Previously, we looked at graphs where your location was changing, your distance from some starting point, okay? Before, we were looking at where you were moving. We could actually say you moved so many meters away from where you started from. Here, we can't do that. This is telling you speeds. This graph shows you that at 1 second, this object was traveling at a speed of 4 meters per second. At 2 seconds, this object was traveling at a rate of 8 meters per second. At 3 seconds, this object was traveling at a rate of 12 meters per second. So before, when we looked at a distance time graph and we saw this nice straight line on a distance time graph meant that they were traveling at a constant speed. Speed wasn't changing. Here, however, you can see that as the line goes up, speed is changing. Speed is increasing. We are increasing at a constant rate. So we still have a straight line, but it is increasing. Before distance time, it meant that speed stayed the same. Now it's showing you that we are speeding up. Whatever this object is increasing in velocity. Draw this graph. Make sure you label it.